So loud. All right. Lots going on over the next couple of weeks. Quick reminders that we have an exam on Friday. I was just planning that since we are so close to the end of the content, why not dedicate an extra day to review for the exam? Because other than that, we're just going to be floundering for things to do next week since we're just about through what we're going to get through. And I still want to give people a little bit of time to work on the project or homework in class and ask questions about that. But I don't think this is going to get in the way of that. So we're going to do a 2-day review. I will field most questions that you have tomorrow because that's what I said that I would do, but I want to at least start throwing some practice problems at you so that we can iterate, you can figure out what you would like some additional practice on, and then you will have a little bit more time to get practice on that before you take the exam. Then next week we have our last project and last homework due. Questions before we dive into some practice problems? All right, first problem I have for you is a Turing machine. These are designed to be more like exam questions. So these are not challenging homework questions. These are more so for you to get data on how intuitive is it to throw together a problem like this? How quickly and easily can you get started? Where do you get stuck? So, Turing machine to remove the first A from a string over AB. AB star. For any Turing machine program, I will say that you can use any Turing machine variants that we have shown to be equivalent to a one-take Turing machine. So this is not just a one-take Turing machine question. Necessarily, to whatever extent that helps. Oh my God. I decided we're going to do a 2-day review. So we're doing exam practice problems. And these are targeted to be the kinds of questions that I would throw on an exam.
When you say remove, do you mean just like replace it with a blank or?
I mean, so this is going to be a transducer. The the resulting string on the tape should be the string without that A.
Okay,
So
it'll
if it was the, yeah, it'll shrink it. I like this problem a lot because there's an easy way and a hard way. Who thinks they found the easy way?
Didn't you say that your tape would be the easy way?
Like I said, it's a possibility. I think there is no reason to use a second tape in this case if you're thinking the easy way. That doesn't have the answer on the tape. The easy way that is correct.
Wouldn't you just have like two states where you just loop it on, well, it would probably just be, yeah, two states, is you just loop the initial state on a B, replacing every B you see, and then the first A you see, you would replace it with blank, moves to the second state, and then that will loop on A or B, and then once you reach a blank there, you just accept.
That is the hard way.
Could you replace the first A you see with the B and then the first B with the blank?
Yeah, that's the easy way. So you don't even have to find the A, you're just gonna split immediately. If the first character is an A, replace it with a blank and you're done. If the first character is a B, replace it with a blank, move till you see the first A, replace it with that B. Yep.
What?
Let's
Because if you replace the first B with a blank, then you lose that B, don't you?
The idea is you want to go replace the first A with that B. Since there's only A's and B's in this string, which of these is going to have some juice? It's about time to replace all of these. So, I mean, your two options are you have a string that starts with an A, doesn't matter what comes after it, you replace that with the blank, you're moving the blank that was here over, deleting that first A, and whatever is left is your string. But if you have a string that starts with a B, maybe it's a B, then an A, then some other stuff. You just replace this B with a blank, store that you saw a B there, then replace this A with that B. And that, now the rest of that string is going to be the same string that was here, where this B is now replaced with the missing A. I don't know how to represent that A is missing, but this just shifted there from that. If you have a string that starts with a bunch of B's, followed by an A and some stuff, you replace this B with a blank, move all the way over, making no changes, replace that A with a B, and whatever comes later is exactly that same string with that A removed. That is the easy way. Yeah. The diagram for it, the Turing machine. Anyone want to take a stab at it? We've reached the point where I want to start seeing people's diagrams on the board. Anyone want to give that a shot? Yeah?
Try it.
Yeah. Do you remember that you're on recording for whenever that matters?
Yeah, so much pressure.
No pressure whatsoever. No one watches these, trust me. I have a YouTube channel. Hello to literally nobody who's not in this class. Although, very funnily, occasionally, if you stay on the white, then people who are remote can see you. I would start it further over further over there. Yeah, basically, I have the camera set up in the back to whatever is is white, and that lets me know that. Occasionally, one of these videos gains random amounts of traction. Like one person discovers it.
Occasionally I get like 1 million views, but.
It's not 1 million, it's more like 20 or 25. But some other class will find this. One person will find it, wow, that was explained in a way that shares it with the rest of their class. But that's the extent to which any of these videos ever get any traction outside of this small group. So it really is not a lot of pressure. The entire world is not watching you. Although, watch, once I become famous, everyone's going to go back and watch the entire history of all these videos, and these a lot of them.
Some just, I don't know how to handle educations, I guess it's my biggest problem, like, if it was, because it's over AD star, so what if there's just nothing to remove? But if
Then you should already, there's no first A to remove, in which case the output should be the same.
So you set the final state for like you, the first thing you're using blank.
Yeah, I would just make Q0 final.
Okay, that makes sense.
Yeah, then basically we say, if there's an A, the first character, replace it with a blank, move right, we're done. That is the first A. Otherwise, we replace the first B with a blank, move over every B. Once we see an A, replace it with a B, move right. Yep, I believe that. Yeah,
And then because this is only concerned about removing that first A, and because the alphabet's only the A and B, we don't have to worry about like reading the entire string.
correct. Yep. We don't need to validate that it's over AB star. We're going to assume that it's over AB star. Yeah. If we somehow saw some other character other than an A and a B while we were looking for it, we would halt and reject early. But yeah, there is no reason to assume it's not in that form. And validate. Yeah.
State or needs against after that initial A?
We do not, just because at this point we've replaced that A with that B, so we've already removed the first A. So be the validation question of just making sure that it was all A's and B's in the first place, which you could do on an exam. I would not penalize anyone for that, but I would try to make it clear that you don't need to validate the rest of the string. Is that in the question? If for some reason I didn't, then I would accept both, a validated or unvalidated solution.
The way I did mine is that eventually if the first A is in the middle of the string, it just makes it blank. Is that incorrect? Because then we have.
Yes, because then we don't have the resulting string anywhere. If you're thinking of reading this like a C string where you're reading up until you see a null character, then you'd be reading up until you see that blank, and that's not the resulting string with the A root. So when we say remove the first A from a string, we're looking for the end result to be that same string with that first A removed. And if there's a blank in the middle of your string, that's two strings. All right, any questions on this problem? Thinking about it, I recommend when you see a question like this on an exam, it might be worth thinking for 15 seconds. Is there an easy way to do this? Easier than just a brute force way, because that will save you well over 10 or 15 seconds if you try to think of an easier way to do it. And I like to throw those kinds of questions on the exam where regardless of how you think of it, it's possible, but it will save you a lot of time, effort, and places where you might go wrong if you think about it the easy way. Any other questions about solution? Right. Second Turing machine. On our tape is a binary number. We want to add 1 to that binary number. Nope, add 1 like numeric. So if our tape is 11001,
But if it's just zero, then we can just add one.
Yep.
So there's like two cases. Is that a good way to approach it?
Potentially. Solution.
So.
Want to draw it on the board? Sure. Yeah, do you want to draw it on the board?
Give it a shot.
Yeah, that's actually, I want to do it. Why not?
Why don't you sit down?
How are you coming up with these solutions?
There's somebody else out there. Yeah, let's be clear.
All right.
Or Norman, you want to draw one as well? We can compare.
Okay.
Oh.
No, I already drew the solution.
It's up to you.
Yeah,
I'm not going to make you do it.
We're bored, okay.
I didn't even have a solution anyway.
I was joking about just sitting down and having you teach this today.
There's no. If you want me to embarrass myself, I'll gladly do it, but
There's a limit to that.
there's a limit.
It was a stupid idea. I think it's how you do it. I think I like that. So you're moving all the way to the right. When you reach the right end and fall off the end of the number that's on the tape, you're going to move back left, looking at this point, you're in Q1 and you're looking at the last digit. You want to, for each one that you see, replace it with a 0 and move left. So this is, in general, how you add one. As soon as you see a 0, that is the terminating condition that says that there's nothing else that we need to look at. If the number ends in a 0, to add 1 to it, you just replace the last digit with a 1 and you call it a day. There's nothing you have to do to any other digit to the left of that. Once we find the thing that becomes a 1, everything to the left of it stays the same. So we just need to loop, looking at how many 1s does this number end with, replace them all with 0s, and then as soon as we see a 0, put a 1 there, and that adds 1 in the same way that 1, 1, 1 is 7, and 1, 0, 0, 0 is 8. This just says every 1 becomes a 0, and the first 0 or blank here becomes a 1, and that is the equivalent of adding 1 to something that ends in a bunch of 1s. So in this case, I agree.
I think the only thing I could think of is like, maybe I could add an extra state, because you have something like 1, 1, 1, 1, and you want to add a 1 to that, you would just want to put,
You need a blank,
yeah,
not a
you-
0.
yeah, you read a blank here. And I guess you could just do, actually, you could just do,
Yeah, the
Blank.
same. Yeah.
and then replace that with a 1. and then that's,
Yeah.
because then it would just add a one and then, oh,
And the rest be zeros. Yep. I like it. Anyone have any other thoughts with regards to this? Anything you see that is wrong that could be fixed, that is incomplete, edge cases? Yep, very much like a type of question I could see myself throwing on the exam. It's something that I think people can throw together in a reasonably short period of time. It is, if you don't know how to add one to a binary number off the top of your head, it's something that you can figure out in a relatively short period of time and come up with those cases. And the actual construction is pretty small. I'm not going to throw you a 15 stater on the exam. That was for the homework. And even that was a little rough. All right. Let's try a context-free pumping lemma. So this reads a to the I, b to the j, c to the I, d to the j, such that I and j are both greater than or equal to 0. True that that is not context-free.
So in this case, can we have a string like A to M, B to them, C to them, D to them, even though I and J are different variables?
Yes, you just set them to be the same thing.
Okay.
We just know that the number of A's and C's must be the same, the number of B's and D's must be the same, but there's nothing that says that the number of A's and B's have to be different. How are we doing? Who wants more time to work? A little bit. Anyone want to walk us through the cases? Yeah.
So if you do, you choose W equals A to them, B to them, C to them, D to them. That element of L, so you're fine.
Let's write that out. We can say that our okay.
And then you could have, because the length of EXY must be less than or equal to N, and you could be, and the length of VY must be greater than or equal to 1. you must be contained within those those substrings.
Right.
And either all A's, all B's, all C's, all D's, or
Or a single overlap.
A's and B's, B's and C's, or C's and D's.
Yeah, so we end up with 7 cases. That is way too many cases, even on an exam, to go through on a case-by-case basis. So how can we bin these together and try to group them in a way that we can make a reasonable argument for some number of these together?
Case 1 is all individuals, case 2 is combining.
So yeah, if they're all individual, then we just need to say that when we increase the number of A's, we can map them to say that it's not the same as the number of C's. Same thing for B's, we would just argue that you're either looking at A's and C's or B's and D's. And whenever you make a change to one, there is a mirror that you're not making a change to. So that's at least the intuition part of it.
Is it mathematically represented as m plus the length of Vy?
Yeah,
Design plan.
Yeah.
So we can say that.
since we know that the length of Vy, really, this should be Vy is greater than or equal to 1. We know Vxy has to be less than or equal to m, but the length of Vy has to be greater than or equal to 1. So when we add Vy, the length of Vy to something, we know there has to be at least one of it, therefore they can no longer be equivalent, and they have to be according to the language definition. Okay, what about the overlaps? Same idea, where you overlap A's and B's, you're making changes to an I and a J here, but not to the mirror I and J and the C's and D's. When you do the same thing for C's and D's, the mirror is the A's and B's. When you do the same thing for the B's and C's, the mirrors are the A and the D. Since we're just counting the number of them, then we know there is always a place that we need to be making a change that we can't be making because the length of our sliding window is at most n characters.
Mathematically, we break down the Vy into 2 variables.
Yeah, you're gonna be making changes to the number of I's and the number of J's, where you know the combination of those is between 1 and m as the.
Right.
So if it were broken down in a way such that the sliding window made Vy was all B's, and we're looking at the overlap of B's and C's, and that would break down into the individual case 1 case of all B's. So we can make an assumption in our case 2 that is the overlap, so there's at least 1 character from each that is part of Vy. We don't know which one, whether it's B or Y, that does that, but if you make the argument based on the number of characters, it doesn't matter. There's an additional argument that you could make, like let's say this is on the border of the B's and C's. It could be that this is B and this is Y. And now when you repeat B, you get some B's followed by some C's, followed by some B's, followed by some C's. This to me is something that you don't even need to consider here. Because if you just focus on the number of them, this is only something you should take into consideration where it's important. There is no number of them that you can attach yourself to, where you break the form of the language. But when we do have this case, we're still messing with the number of B's and C's compared to the number of A's and D's. So whether we're breaking the form of the language, the ordering of the characters doesn't matter.
So on an exam for this, I call it a template.
Yeah.
The length of Vy, the way we would represent this is we would break down the length of Vy into like L plus P. And then we would say, like you're saying, that because we already covered the cases with all A's or B's, we're saying that at least one of them must be 1.
Yes. And at least one of them must be the other. So if you broke it down into an L and a P, then you would have, you'd have A to the M, B to the M plus P. That's the used or your 2 again, L and P, M plus L, C to the M plus P, D to the M. And since we know that L and P are both at least 1, because if they weren't at least 1, we could represent this case as one of the case 1 cases, which we've already shown to not be possible. Then we can show that M plus L is not equal to M, and M plus P is not equal to M.
Yeah, I just wanted to make sure because I think this is easier to show on an exam than explaining it, being like,
Yeah,
You know?
yeah, absolutely. I think that whatever it is that you attach yourself to for your language, hopefully your homework gives you some good feedback on how that language works or not.
okay,
What I find to be the big difference maker between exam success and failure is whether you can attach yourself to the intuition. Once you can attach yourself to the intuition, you just have to find a way to explain it in a way that works. And that's what absolutely works. Any questions on the logic of breaking this problem down into its 7 cases, combining those 7 cases into a couple of templates and making generic arguments based on those templates? I think that would save you the most time and make this answerable in a reasonable period of time. Any questions? Anything else we want to go over with regards to this question?
we don't need a pump up or anything, we're just proving the logic here.
Basically, when you do pump up once, you said I equal to 2, then we
Like
get
given.
this. Yeah,
Okay,
you get this result. So yeah, you do want to set I equal to 2. You are pumping up once, but the result of pumping up once creates that inequality between A's and C's or B's and B's, regardless of which case you're in.
Would pumping down also work? Like,
Yes.
is these-
Yeah, any pump here would work. Pump up, pump down, pump up by an arbitrary amount. I equals 3, I equals 12, I equals 0. Whatever you do, you would just scale this M minus L, M minus P if it's I equals 0. M plus 12L, M plus 12P. Doesn't matter what you do. It's not going to be equivalent regardless. Okay. I think we have time for one more, or at least to get started with it. Let's make a non-deterministic Turing machine to recognize composite numbers. As a deterministic Turing machine, this would be disgusting. That's a 210 level homework problem. But with non-determinism, it becomes a little bit easier. I would say that 0 is not a composite. I'm not gonna worry about 0. You can expect that there is a number that is 1 or greater in this game.
I go to the one at the top, I don't need the bottom, then if I don't, then I have a bottom, and then a divider. That's the point. Triggers a simple solution.
Can I brainstorm?
Yeah.
If, so what I'm thinking is a composite number will always be made up of even parts.
Mhm.
So 4 is made up of 2 and 2, 9 is made up of 3, wait, 3, 3, 3, right?
Mhm.
So what if we put a marker non-deterministically for every one of those parts and kept testing them? Or is that, am I going
Kind of on the right track.
kind of?
So there's gonna be some divisor. For every composite number, there is some divisor other than 1 in itself.
Right.
So the idea would be start with the first possible divisor on a second tape. So 2 is the smallest possible divisor for a number if it is even. You will want one process that checks whether this number is divisible by 2. And you want another process that's going to prepare the next potential divisor, which is 3. It's going to prepare that and then send that down the same conveyor belt. If we're using the conveyor belt idea, we're going to send, is this divisible by 2? At the same time, we're going to set up, is this divisible by 3? At the same time, we're going to set up, is this divisible by 4? And while all of those conveyor belts are working, we're just setting up the next possible divisor until some termination condition. How do we know when we've checked every potential divisor? And you may remember from 210 that you only have to check up to the square root in order to be sure. But on a Turing machine, that's going to be a little bit difficult to verify. When is something the square root of another number? Rather than think about that, use a less intelligent termination condition. Like, check every number up to the number. That's easier to recognize on a Turing machine.
So for checking, like on the second page for the divisor, I guess you would probably start with something like, you would fill the second tape with 0s equals the number of 1s in the first tape, and then just start filling, like replacing left to right of 1. And then once you get a blank on the second tape, you know you've gone up to that first number and then you can terminate that it's not divisible for it is.
I don't think you need quite that many zeros. So if we're looking at, let's say, the number.
Yeah, you're probably looking at that many zeros. You probably get by with even just like half as many as.
I'm just gonna say do this. And we know that there are blanks on each side of the number. We know there are blanks on each side of the potential divisor. So start looking here and here. Whenever we move right and see a 1 on tape 2, we're gonna move right on tape 1. When you fall off the end of this, instead of moving right on this tape, reset to the beginning. And you're looking for hitting these blanks at the same time. If you hit these blanks at the same time, then this number is divisible by that number. If you hit this blank and you're not on a blank here, this number is not divisible by that number, and we can terminate that process and reject. But non-deterministically, we've made some more of those, and they're also working at the same time. So we just have to go thread by thread and determine, does a thread accept or reject? While another process is making every possible thread to check. So basically, we have a process that creates this and passes it down the conveyor belt. Then we have another that is going to, as this says, go do that, it's also preparing that at exactly the same time. One step later, it's going to send that down the conveyor belt to determine acceptance or rejection. And then this process's next step is going to be to create the next problem. So on step one, this is getting sent down the conveyor belt, and this is being made. On step two, now we're a step into verifying this. This is being sent down the conveyor belt, and the next one is being made. So it becomes kind of like a tree of, we've gone n steps down this, n minus 1 steps down this, n minus 2 steps down the next one, all the way down, and we have n threads running. As soon as any one of those threads says yes, the entire process, all of the conveyor belts stop, and everyone throws a big party. Well, we're out of time for the day. I'm going to leave this one hanging. Feel free to work on this between today and tomorrow. I think this is good practice for thinking non-deterministically and what might be something like a reasonable challenge problem to throw on an exam. I would not throw something quite this difficult alongside a bunch of other questions that are this difficult, but maybe it's the one challenge problem I throw on the exam. So you should feel comfortable throwing together a solution for something like this in a reasonable amount of time. So we'll come back and I'll see if someone can put a solution to this on the board at the start of tomorrow's class, and I'll also field any extra questions that you have, as well as some questions on countable and uncountable sets that I can deliver to you. So I'll see you tomorrow for that.